Hello everybody, welcome back. Hopefully I have my microphone working now. You'll see that we're in the middle of a project and you haven't actually seen this part of the project, and that's because I was a dum-dum and I started recording using the new microphone that I got set up without actually fully testing it properly first. So I went to start editing the video and found that there was a AC coupling hum in the background that was so loud that it actually drowned out my voice. The microphone was working, but if I tried to run the iPad with power, there was this horrible buzzing noise. Now, with it not connected into power, the horrible buzzing noise isn't there, so I'm having to re-record the portions of the video with that, need audio, but of course, I've already done the project. So what I'm working on here is something called a Herrnhuter Sterne, which is, see, Herrnhuter, which is a German Christmas ornament that frankly looks a little bit like a torture device. So this is what it looks like. And you plug a light into the top here. One of my spikes broke off on this one. But a light goes into the top there and it glows. And when I saw these at the Vancouver Christmas market, I thought to myself, boy, that just screams do something to me with LEDs. So I bought a second one in all white. Oops, in all white. So these are the spikes that you glue onto the center core, and these are the shells for the center core. And from there, I started working on a bit of a proof of concept off camera, which is this part here, where I glued the LEDs. I'm using 3 and 5 millimeter diffused lens color changing LEDs in this thing. I glued them in, and then I soldered them all in parallel with this enameled magnet wire, because you can sort of chain it together, because as you solder it, it destroys the enamel so that you can do the soldering connection, but the rest of the enamel remains intact, so you can continue the chain from there. So the problem with doing it that way was that I noticed that I was starting to melt the housing accidentally with the soldering iron while I was starting to work on it. So I needed to come up with a new way of doing it. So then I had a brainstorm a couple of days ago where I came up with this. And basically this, pardon me as I rummage around for all of the things that I need to actually demonstrate it. Where are my 5 millimeter LEDs? I don't know, but I have a couple of them here, so I'll just, or 3 millimeter LEDs rather. So here, what I basically did, because I'm using a mixture of 3 and 5 millimeter LEDs, I just dug 3 and 5 millimeter holes, and lined them up correctly for polarity, like so, and chained the magnet wire along and soldered them all on, and that's how that went. And that worked brilliantly. As you can see here, nice long chain of the LEDs that I need from the remaining points. Now, I'm going to go ahead and clip over to the time lapse for that portion of the project, and then I'll come back and I'll show you the rest of how this worked. So let's go ahead and go watch that time lapse. Okay, there we go. I'm hoping that was at least somewhat entertaining. Anyway, so now we're at this point where I actually get to show you the culmination of the project now that it's ready to power, or at least test with power. So this is the current limiting resistor that I'll be using for the circuit right here. And I came to the conclusion that I needed that through a somewhat long process, but on my little prototyping breadboard over here, I took all 25 LEDs, put them in parallel, and then I took a potentiometer, cranked it all the way up to the top. It was like a 2K ohm potentiometer, so there was no way those lights were gonna come on with it turned all the way up. And then I hooked my M meter into series with that, and then I started turning the potentiometer down until not only were the lights lit and functioning, because they do have a little bit of circuitry in them that determines their color changing pattern, but so that they were bright enough for my purposes without being too bright, because I want just an ambient glow. I don't want it to like light a room. So I discovered that that amount of current was 160 milliamps. And then to figure out what kind of a resistor I needed, I calculated out that I'm going to be powering it off of USB, so we need 5 volts. And then the LEDs are rated for a maximum of 3.4 volts, which leaves us with 1.6 volts, which is really awesome because it makes the math super easy. We've got 1.6 volts, we've got 160 milliamps, we need to figure out what the resistor is. You divide 1.6 volts by 160 milliamps, and you get 10 ohms. So I'm going to use a nice beefy 10 ohm resistor for this. That's black, brown, or brown, black, black, 1, 0, and then a 0 multiplier. And then hook it into the circuit. So I'm actually just going to go ahead and show you what this looks like now. Which way did I connect this? Okay. I'm going to put this on, and then I'm going to put that on, make sure I've got it plugged into the 5 volt power supply, and then I'm going to turn it on. It's interesting that that one went straight to blue. Anyway, so you see they all very slowly change colors all on their own. This one's way out of sync already. The idea is that they actually should go out of sync eventually. I actually did a brief video right here where I actually demonstrated my proof of concept when I had it all connected up to my breadboard. But this is what they actually look like in operation the way I envisioned them. So that's enough for this video. I'm going to do another video on this where I take these LEDs and I finish up the clamshell and glue the spikes on, and then show you the finished product at the end of it all. So hope you enjoyed watching. Give me a like and ask any questions in the comments below. I'll have a link to subscribe right about here, and a video that Google thinks you might find interesting right there. So we'll see you all in the next video. Bye-bye.